What we'll cover today is that using the data from the software projects that we've collected in the ISPSG repository, we're going to have a look at how people have gone about estimating their projects and how well they did it. And we'll look at the estimation techniques that they used and the accuracy of estimates and the relationship between the various estimates. Are there any patterns and things for us to look at? We'll then offer some practical tips at the end that I think you'll find very useful based on the data analysis that we've done, which just help you in your estimation, help you in doing reality checks on estimates that people perhaps put to you. And you can work out how realistic your own estimates are. So if you could flick to slide 9, please, Michael. Just to cover the principles of the ISBSG, it's an independent organization that is not-for-profit. So its members are all not-for-profit at this stage. They're a group of organizations that are primarily interested in making sure that the industry has a database of independent history data we can work from. All other engineering disciplines have history data that they use, and it's important that the IT industry has access to some good history data. And that's what the ISBSG does. It's simply in business to provide history data to the industry. We go to a lot of trouble to try and ensure high quality and the integrity of our data. People who submit data to us, we protect them, the security and anonymity. We've never had a problem over the 18-year period. The practitioners are the people that are driving all this, so people tell us what they want and we try and service that to meet their needs with regards to the availability of data. And we try and make the data accessible at a very reasonable price so that people can look at the data, criticize it, use it, do what they like with it. The data is available via subscription, via an online portal, and in the next few weeks we'll actually release the data once again on an Excel spreadsheet. So you can pay for just what you want on the portal, a few $100s, or you can take out a subscription to the data and have unlimited access to all the data. If you could flick over to slide 10, please, Michael. What you need to know before you start using the data, or even before you're listening to me today, that there's a warning, really. The ISBSG data is not your industry average. If you think about it, anybody that goes to the trouble of sending data to us is probably a pretty mature organization. So we have a guess that the data we've got probably represents the top 25% of the industry. And that's pretty important, because if you're going to use the data or look at the results that we're going to show you, you need to think, well, where am I placed? If you're very mature and you're in the top 25%, in your opinion, then you can actually use the data and think, okay, I can compare myself to this data. If you're dealing with an organization that is not that mature, then you may want to make adjustments. Well, you should make adjustments. So, for example, if the ISBSG is saying that for a certain language or project or whatever, the number of hours you would spend producing a function point of software is 12, then you need to add a percentage if you don't believe you're in the top 25% of the industry, if you've got a less mature organization. So just keep that in mind. This is what we think is good data from mature organizations. The other thing, of course, is that we only have successful projects. By that I mean projects that are finished. And that may be why we don't have a lot of large projects. If you could turn to slide 11. Thanks, Michael. So what estimation data do we collect? We try and collect data for duration, how long a project will take, the effort involved, the amount of hours that go into it, the cost, in various currencies, of course, and the project size. Not all the projects in the data set that we have data for all 4 of these types. So we rely on people giving us data. And in some instances, they don't give us everything that we'd like. So we don't have 6,000 projects with data in all 4 fields. But we have very large data sets now. Because we've got 6,000 projects, we can get very large data sets with good data in them that we base our analysis on. Okay, moving to slide 12. So let's have a look at the results. Just how do we go when we do estimates, and what does the ISBSG data reflect? If we look at effort and delivery, if we look at those two together, a quarter of the projects actually met both estimates. So if you look at the ISBSG data set, 1/4 of them met both estimates. Now, by meeting both estimates, we've allowed a little bit of leeway here. 11% were better than expected, which means the estimate was very conservative. And 14% were pretty well on what the estimate was. That's the good news. 39% of the projects in our data set met one but not the other. Okay. So 25% were on time but used a lot more effort, which I guess we're all used to. And I'm aware here of a comment from Cabus Jones, who he and I are regularly in contact, and he's always reminding me that one of the difficulties in our industry is that people don't always record all their overtime. I think this 25% that were on time but used more effort, perhaps they are recording their overtime. We do our best in our questionnaires to make sure that we cover that, to encourage people to make sure that the effort they're entering into the data reflects the overtime as well as their normal time. So 14% were late, but they didn't exceed the effort estimate. So perhaps other things got involved. Perhaps there was some delay. Perhaps they moved office in the middle of the project or something. And then about 1/3 missed both estimates. They were delivered late and they ran more than 10% over the estimated effort. So we're giving people a bit of slack here. We're saying that if it was within 10%, then that's okay. But these ones, this 36% of them, were actually over 10% of the effort that they estimated. If we move to slide 13, some observations that we have. As you would expect, smaller projects with short durations were the one that were the most accurate. These were the most accurately estimated. Poor estimates, particularly for delivery date, tended to be new developments. And I should explain to you here that our data set has two types of projects in it. We collect data for both new developments and for enhancements. And you'll see a couple of comments about the difference as we move through this presentation. So new developments tended not to be estimated as well as enhancements. And also, projects with a large number of users, they in the data set that we analyzed, they also showed that they tended to have poor estimates. So if we move to slide 14, let's have a look at an observation on cost. This might seem obvious, but statisticians love to prove things. So the errors in estimating correlate with the errors in estimating effort. So in estimating cost, as you would expect, people work out effort. That tends to be the driver for cost. You multiply that out by your hourly rates. So statistically, effort and cost are strongly related. And that made my analyst feel much better. So this supports the intuition that, cost is determined by the effort involved. I mean, obviously there are other cost factors, but the primary one seems to be effort. So productivity in estimates, this is interesting. You might think that if an estimate is accurate, people are delivering on time and within the effort, that they might also have very high productivity. And by productivity, that's a very loose use of the word. I mean, we provide productivity figures on what we call a PDR, which is the project delivery rate. This is the number of hours